Thank you very much for joining us this evening for Discourse Topic of the Month on RESTful APIs. What we're going to be doing in this topic of the month, we're going to be doing a live stream each week. Each week we're going to be doing some Q&A sessions, we're going to be taking some deep dives into some of the topics that we're talking about, and we're going to be building a RESTful API for a to-do list application. Deep dives at relevant subjects, Q&A sessions. There'll be a GitHub repo for this project, I hope. I haven't asked Lost about it. But the idea is that we're going to have the repo for this project public, so you guys can contribute to it, you can fix bugs if you so desire, you can open issues and get featured on live streams. What we're actually building in a bit more detail, it's a to-do list application, the standard one that everybody seems to build when they get started, except we're going to be doing it as an API. So the term for that would be it exposes a RESTful API. There's going to be no front end needed. If you are useless at front end like me, it's absolutely not a problem. You do not need it for this topic of the month. We're going to be using persistent storage, using either SQLite or Postgres. I think I've got this project set up using Postgres, but you can use whatever you're familiar with. We're going to be featuring user accounts, so to-do items will be tied to specific accounts. We're going to be using authentication and authorization to lock down what can actually be done with the specific items. So say you can't delete another user's to-do items. We're also going to be using JSON Web Tokens, or JWTs. These will be the tokens that we use to authorize access to the API. And since it's topic of the month, and we're going to assume that there's going to be people here that have never heard of an API, let's have a look at the 10,000 foot view of what an API actually is. An API is an application programming interface. It allows developers to interface with your code in a controlled way. In the context of the web, that typically means a RESTful API. In a nutshell, a RESTful API is a web service that responds to HTTP requests. It changes its behavior based on what request verb is being used for the request. So if you submit a GET request, it will retrieve information. If you submit a POST request, it will create something. It's also stateless, which is one of the challenges that you're going to be working around when you're building APIs. In a nutshell, this means that every single request that comes in is brand spanking new. The API has never seen it before. No information is carried over between requests. Speaking of challenges, what are the disadvantages of using an API versus a more traditional structure like, say, a Laravel MVC application? One of the first ones is that requests are usually allowed to come from anywhere when you're dealing with an API. This means that there are a lot more targets for an attacker to hit because you have to expose URLs that actually do things in response to a request. Authentication and authorization is another major challenge when you're working with an API. You don't have sessions and you can use cookies, but it's not recommended because you can't guarantee what type of client will be making a request to your API. It could be a laptop, it could be a phone, it could be a smart fridge. You have no idea. So as a general rule, avoid using cookies when you're working with an API. Use tokens instead, which is what the JWTs are. Disconnected clients is a term that would best describe clients that are not within your control. It's typically when you open an API up to the internet, other parties, third-party clients, that sort of thing, can build their own applications which interface with your API. So you don't have any control over this. So one of the examples for this would be in, say, a Laravel application, you can echo a variable directly into a view. You're not doing that here because you don't have control of the application which is accessing your API, typically. So we've had disadvantages. Let's have a quick look at some of the advantages, and then I've just spotted a couple of questions that I'm going to answer. The first advantage, APIs can be blisteringly fast. It's amazing because there's no views to render. It's just JSON, which is basically text. Next big advantage is that APIs are client agnostic. This means that an API does not care what is making the request to it. Again, it could be a phone, it could be a laptop, it could be a smart fridge. If it can make a web request, it can interface with your API. The next one is an ultra fancy term that I absolutely fell in love with after I heard it at my first dev job, which is delegation of responsibility. In a nutshell, it means that if you open your API up to other people and they can build their own applications to work with it, you can say, don't let my client build your own, Mark it as a won't fix, crack on with your day. Oh, ow. I'm just going to move on to a couple of key terms while I nurse my toe that I think I've just busted, and I'm going to answer a couple of questions. So what do I mean by view? A view would be a page which is rendered in response to a request. Like when you visit, say, Google, the page that you see, that would be a view. Speaking of Google, my phone's just piped up. You wanting a quick break? Now would probably be the time to do it. Leave us a couple of minutes for you to read through this slide because it's just a text dump. Which client will you be using for testing / developing the API, and why that client? My default client that I tend to use when I build an API is Postman. There are other alternatives to it. I think Insomnia's one. I think there's also Postwoman as well, which is kind of like Postman, but it's browser-based. I use Postman primarily because it's force a habit. I started using it a long time ago. I'm very familiar with it. I really like it. If anyone has any other questions, I think now would be the time. Leave it a minute, and then we'll just move on to the last slide, which is a big one when you're working with APIs.
Yeah, I have a question. What if you have an application that does track sessions? Because that's what we're doing at work. We've implemented an API in a software that previously just uses like simple views in PHP and tracks the user's login via sessions. And that still persists through the implementation of a new API, and the PHP can like still access that session as long as the user has logged in normally. So there's no login over the API, but then it stores that. Is that a bad thing? Should we change that?
I'm assuming that after a user's logged in, you go and get the information for that user out of the session.
I don't know the details, but the API is only like for certain newer pages. Everything else is like very traditional.
Yeah.
Um, yeah. And so it has a, I think, I'm not sure. I think it has a session cookie, and I don't really know how that works. But the browser seems to just send the cookie as well, even though we don't configure fetch to do that.
By default, if I remember it rightly, when you make a web request, if that API is accepting, I think there's a field for it, accept credentials, I think it is. If that's true, it will read the cookie from the browser that made the request to it. So that's probably
Oh,
why it's sending a cookie to it. As for
okay, but we didn't configure that. The entire API thing is completely handmade. We made that all just bare bones, simple PHP. I will probably look into that, but I just want to like
yeah, I'll
kind of
have a quick
ask.
look into that one as well. I'm quite curious why it's able to access a cookie if that
Yeah,
field isn't set. That's
yeah,
interesting, is
because
that one?
because for testing some API endpoints with Insomnia or like with any client, uh, I had to add the cookie manually, so it wouldn't work without it. I mean, that would be a problem, obviously, because then anyone could make any requests, and yeah.
Yeah, when you're
All right.
stuck
Oh,
halfway between using like old style sessions and then between tokens as well, it's the way that I've done it for a project that I'm working on at work is the API. It is built into the monolithic MVC application, but the way that it works, it parses the token and stuff, validates it, makes sure it's all valid, and then it hooks into the existing logic, which sets the user based on the session. So it hooks into that and just kind of makes a fake cookie for it, which never actually gets set in the browser. That's the way that I've done it there.
okay, I see. Uh, Thanks for answering.
No problem.
That's all.
I've got another question. Is an API just a way of grabbing information from a certain source? That would be when you're consuming an API, if you're making requests to it. The API is the other side of that, which is providing the information. Why is an endpoint a URL? Wouldn't it be a server? An endpoint is a URL on an API which responds to requests. So one of the key features of an endpoint is that it changes its behavior based on the verb that's been used in the request. So you could submit a get put and a post request to the same URL, and three different things would happen, or can happen, depending on how the API is built. So if everyone's good, we're going to move on to the next one, which is a really big one that everyone struggles with at some point, and that is CORS. This is the junior stumbling block when you work with APIs. It stands for Cross-Origin Request Sharing, and it defines what URL is allowed to send requests to this service. So typically the way that this is set up on a public API is that it will accept requests from absolutely anywhere, it doesn't care. But a lot of times you'll find in usually enterprise kind of settings that they tend to lock down their CORS policies, so it only accepts requests from, say, an internal application. This trips absolutely everybody up at some point. Everybody has struggled with this. I've struggled with this. I feel your pain. I'm here to help you with it, don't worry. The other thing with CORS, it's literally just a header in the response, and it's access control allow origin. This is what defines what URLs are allowed to make requests to this API. If you set it to an asterisk, like it is on this slide, it will accept requests from anywhere. You'll have probably seen when you're working with APIs on the front end, this tends to manifest in the form of a second request that goes out before the actual request. So if you're wanting to make a post request to an API, if you look in the network panel, when you click the button and it sends the request, you'll usually see that there's a second request which goes just before your first one, which is an options request. This is what's called a pre-flight. The pre-flight request makes a request to the API, just using the options method, which is typically one that doesn't actually perform any logic, and then it checks the responses headers. And if it doesn't see an access control header, or if it sees an incorrect access control header, it'll stop the other requests going through. This is a holdover from ye olde days of the web. There's a lot more information on this in the MDN article on CORS, which is in the I think it's in either FAQ or resources for the topic of the month. It's a really fascinating read that tells you all about why CORS is actually here and what it does. But I won't explain it because I'll be here all night. There are packages available on npm and Packagist, and I can imagine there's some other ones on like Python's package management and on NuGet, which can auto-magically solve this problem for you. I would recommend that you don't use them, because it all gets a little bit complicated. If your application is sitting behind something like Apache or Nginx, these packages won't do anything for you. So you'll need to learn how to solve it properly using those solutions. And another URL which I've posted in the resources is enablecors.org. This is your best friend. This service is absolutely magical. It has guides on just about every possible server setup you can imagine and how to enable CORS for it. Definitely go give it a read. I think there's a donate button on there somewhere. Throw them a couple of dollars, show them some love. So that's the end of these slides. So if anyone's got any more questions, please do hit me up, and then we'll go get started on some code.
Yeah. Would you mind maybe opening the keyword slide up again? I don't think you actually covered that. You just showed it for the break, I think, or like answering questions.
Yes, I did. Just give it just a second, and I'll open that back up. I think somebody took a screenshot of it in chat, actually.
Yeah, it's in the live stream text if you guys want to look at it.
All right, cool.
Is that all right, or do you want me to
I don't
open
know
it back up again?
No specific reasons. Maybe just I don't know. Maybe there are some interesting things that are not like written on the slides that you maybe say something about. I don't know.
Was there anything particular you want me to go over? You lit up, but I didn't hear you waffle. There you gone quiet. It's not me, is it? No, I think all's well on my audio. I can't hear anyone. This is weird. Just a second. Yeah, I'm not sure whether my audio's just gone weird or not, but I didn't hear what you said, Waffle. Yeah, I definitely can't hear you. Something's gone weird. Can you post it in the text chat? So we got another question. Does the authorization / authentication matter as much when you're doing stuff internally, like between your friends? Probably not, but I would say that it's always a good idea to have some form of access control, which is basically what those two things are. Authentication would be the process of verifying that a user is who they say they are. So the way you typically do this, the way you most often see this, is by checking that an email address and a password match up with what you've got. And the authorization is the process of checking whether a user is allowed to do the thing they're trying to do. So that assumes you've already got an authenticated user, and then you'd have to say, look up some permissions in a database and see whether they've got permission to access something.
I think that's Visual Studio, right?
Yeah, I can increase this. For this project, we're going to be using this starter template repo that I put together. And this template repo is everything you need to get started with a TypeScript node-based API using Express.js. So this template takes care of your database stuff, it takes care of JWTs, user accounts, authentication, authorization, all of that fun stuff. I will be making some changes to this as we go. So this will be updated with a few more bits of functionality. Someone mentioned in the chat yesterday that they wanted functionality for testing this, so I'm going to add that as we go along. Probably not during this topic of the month, I'll be doing this off stream. But if you keep checking this repo, you'll see, hopefully, I've added tests and added a bunch of other fun stuff. So now I'm just going to take you on a quick walk around of how things work in this template repo. I'll just put this into presentation mode and then you'll be able to read it. There we go. So the first most important thing that you've got in this whole repo is a sample environment file. So this repo uses .env, I think it's called. So you've got a file at the root of your project called .env, and everything that you define in here is suddenly available to your application. So you can see that we've got configuration in here for the database, specifically for TypeORM. We've got some bcrypt configuration. This is for password hashing, because you never, ever, ever store plain text passwords, ever. There is never a single scenario where storing a plain text password is okay. You always hash the password. And lastly, we've got some configuration for your JWTs. So the way that a JWT works is when you first log in, you get an access token back. This is your JWT. These tokens are usually only valid for anywhere from between 5 to 15 minutes. And then at that point, you'll use another token that you got when you logged in called the refresh token. You'll submit that, and then if that token is valid, you'll get a new access token back. And part of the process of checking this JWT is valid is checking that its lifespan is, you've got 3 different states for a JWT. So you've got invalid, valid, and expired. This seems to trip a lot of people up. An expired token is not necessarily an invalid token. So that's what this lifespan's all about. One of the checks for a JWT is that you'll check the issuer. So that's who actually created the JWT and gave you it. If this doesn't match, it means somebody's either trying to use a token from a different service or they're tampering with their JWT, and you should reject it. And then you've got your signing key, which is, of course, the most secure default value in the world, very secure key. If you do use this template repo and you make something that goes into production, please set this value to something that is insanely long. The longer the better, completely unguessable. So we've got another question. We've got, was it bad that I used pure JWT custom implementation than using something like passport.js? It depends on the context. JWTs themselves, the custom implementation of it, it's not actually that difficult, but it's very easy to make a fatal mistake in there. So I definitely recommend that you really put this thing under test. Give it lots of invalid tokens, start tampering with stuff, wait until the token's supposed to be expired, like 10-15 minutes, and then use it, see what happens. There's a lot of scenarios you've got to consider to make sure you've tested it properly. I'll put some resources in the Backend resources chat, actually, which will help you out there. Can I use any kind of hash, like one-way ticket, one-way ticket, one-way ticket, for example, SHA-3? Is this for the signing key? Because then, yeah, you can use any plain text value here that you like, the longer the better. Because this will be used to generate the signature which goes on the end of a JWT. Which I will show you actually very quickly. Let me just fire up Postman, let me get out JWT. Another question, just while I'm grabbing this. How would you normally go about generating the signing key? Just pull something from random password generator. You can go about it however you want. You could, one way that I do it sometimes is I generate a SHA-256 hash of the current year, month, date and time. That's a way that you can do it. It's probably not the most secure way to do it, but you can do that. As long as it's something that's really, really, really long and completely unguessable, you're fine. So another useful tool, which I'll throw into the resources chat, is this one, jwt.io. On this page, there is a debugger where you can put in a JWT and it will give you back all the information about it. So you can, excuse me, so you can see that this JWT, when it's decoded, is split into 3 different sections. You've got the header, which defines the algorithm that's used to sign it. You've got the type of the token, which is JWT. Typically, this header bit isn't going to change, so you can just hard code it. The payload, which is the actual information encoded within the token. So you can see that this top field sub, which is the subject, that's set to one of my email addresses. We've got a username that I put in that token. That's the user ID.
Can't see your screen.
Can you not?
No, it's the wrong screen.
Ah, you're right. I'm an idiot. Thanks for pointing that out. Yeah, I think that's changed now.
It's good now.
There we go. Yeah, sorry about that. I had it set to WebStorm instead of the browser. So, yes, you can put in a JWT on this page and it'll split it down and decode it into its 3 different sections. So you can see that in the encoded token, there's 3 different colours. You've got the red here, which is your header. You've got purple, which is your payload, and you've got the last one, which is your signature. Each of these are separated by a period. So you can just split the string on the period, and then you've got these 3 different sections. You'd then base64 decode that, and that'll give you some JSON. And that JSON will turn into these 3 parts here. So I've got the header. This is typically just hard-coded. You've got the payload, which is the actual information within the JWT. And then you've got a signature on the end. So what was my very secure key? So put that in, paste the JWT back in, and it'll tell you there that the signature is verified. Now the neat thing about JWTs is because it's got this signature on the end, this cryptographic signature, we can check whether the information that we sent out in this token is the same information that we got back without actually storing this token. So I'm just going to pick a random character somewhere. This 5 looks good. Change that to a 4. All of a sudden the entire thing's invalid. And that's because this signature is... The signature is basically a check mark which says that this is what we sent out. If you can't generate the same signature anymore, all of a sudden it means the token is no longer valid. It means someone's tampered with it. And that's why JWTs are so powerful. And that's also why you can go quite fatally wrong with JWTs and shoot yourself in the foot. So the way that you generate the signature, it actually shows you down here. You take the header, which is this top part, you base64 encode it, you add a period onto the end, and then you do the same thing with the payload, and then you strap the whole thing together and sign it. And that's how you generate a JWT. So I'm going to switch this back over to WebStorm now. If I can find it in the list. There it is. So that's the environment file. which is basically your config file for the whole project. Apparently the stream failed to start, is that right?
It's fine.
Oh good, it's just Discord then. So the next bit you'll probably be looking at is your index file. This is all the startup logic for the application. So the very first thing we do is we import .env and we make everything in there accessible to the application. Then we just do some standard node setup stuff, we start using some middlewares, and then we create the database connection. Because this is using TypeORM, the way that you'd set up your database connection is a little bit different. So you create the connection and then after that you start the rest of the application up. That's how it's been done here. If you happen to know more about TypeORM than me, which probably isn't difficult, and you know a better way to do this, please submit a PR, because I still think this is hacky and slightly weird. So then we run connection synchronize. What this will do is this will compare the state of your database to the state of your entity classes, which are basically just models representing the data in your tables. So it will see whether these two match up. If it doesn't, it will make the necessary changes automatically. So it'll add tables, remove tables, alter tables as needed. Then the rest of the application starts up and we introduce our first bit of custom middleware, which is to verify JWTs. So since we start off with routers, we'll have a quick look at one of the routers in this application. So let's have a look at the auth one. What we do with the routes, rather than doing app.use and then defining a path and then specifying an import, I like to do things a bit more modular, so I've broken it out into full classes. So each of these router classes contains the path that it's listing on. It contains a reference to the express router and it contains a reference to the controller which is behind it. You define your routes down here. So we define a post request to /register, or in this case API/auth/register will trigger the, if I can scroll, the registration action on the controller. I think I need to document this actually on my repo because I don't think I've documented it. So I will definitely document how it all works. Once you've written your routers, you'll find in the index file in each of these folders, it's basically just a grouped export. So it brings in all of the routers and exports them all in a single object. So then you can import just this one file and then you have access to every one of the classes that's in the directory rather than importing each router individually. Next most important bit we'll have a look at is entities, because the database stuff is the heart and soul of just about every API. So we'll have a look at the user entity. An entity in this particular context is just a class which models how your database looks. So if you imagine that this class is a table, the user table, we'd need an ID property, username property, that sort of thing. You define all of the properties that you need in your database in these classes, and then you let TypeORM do the rest for you. It's magical. We have a question. I assume we're supposed to ask questions related to the stream. I'm not sure. Somebody else will have to set that one. One bit where it does get slightly more complicated is when you have entities that reference other entities. These would be your relationships. In this instance, we've got a user entity needs access to refresh tokens, which are also linked to this user entity, because one user will have many refresh tokens, and we need to have a way of linking these two together. So you'll find one-to-many annotations, many-to-one annotations, that sort of thing. I will cover all this actually in probably next week's stream, where I'll post something in the resources chat about it. But I could be here all day going on about entities, so I'm going to move on. We're going to have a look at controllers. So this is the auth controller. This is what defines what logic runs in response to a request. So in fact, let me just open the router really quick. That's the auth router. I'll open that twice. There we go. So in our router, we've defined this router post register. and this will make a call to this controller registration. This will trigger this method here on the auth controller. And this is the whole API coming together, really. This is what it's all about. You route requests to controllers, and the controllers then kick off other logic in your application. So for our registration action, we take a request in, we've got access to the request object, which is what came from the user, and we've got access to a response object, which is what we'll be sending back. In this instance, we take the data which has come from the request, so in the post request body, we submit this to the user service, and then if everything's okay, we get a user object back. And if all else fails, we'll send back a 400 request with an error detailing what went wrong. Now, this is the first thing that a lot of people seem to struggle with when they're building APIs. You can't return a view, so what do you do? How do you handle it? You send back JSON. Where did Postman go? And I will give you a quick demo of how this works. I just need to fire up the... Yep. I'll just fire up another project that I was tinkering around with using this same template repo rather. So let's run this, start the application up. I think Postman's just disappeared again, it's just not appearing in my panel. There we go. So we'll make a request. Let's make a login request. So we send our credentials, and then what we get back is JSON. There's no views involved, there's only JSON. And what you do with this is you would send back this JSON payload, and then whoever is building the application that integrates with your API...
can't see.
Oh, sorry, I've done it again. There we go. Sorry, you're going to have to keep pointing that out to me. I can only select individual windows at the minute. Has that appeared?
Yes.
Marvellous. I've lost where I was. That was it. So, like I said, this is what a lot of people seem to struggle with when they first get started, because you can't return a view. You can only return JSON. So there's no page involved, there's no styling, there's just this. This is literally all that you'll be sending back, and then whoever is building the application that uses your API is responsible for reading this JSON and then doing something with it and showing something pretty. In this instance, because it's a login endpoint, we get back an access token, and on this particular project I've not implemented refresh tokens yet, but that would appear here as well. While we're here in Postman, might as well have a quick look at authentication authorization. So this endpoint, this is a to-dos endpoint, and let me just turn off the authentication for that rather. So if you send a request to that without any tokens provided, it will send back a 401 response telling us that there was invalid credentials provided. This is the standard way that you'd respond in the scenario that credentials haven't been provided in an instance where they're actually needed. So if we swap that out now, and that token will be expired, let me just grab the other one. Slam that in there, make a request, and we get back our to-dos. Because now that we've provided this token, the API can take this token, split it apart, and work out who we are, and then it can actually use that information to go and find the to-dos as required. But if we don't provide this token, it can't do it, so we'll just return a 401, we'll say, come back when you got some credentials. Is everyone following, or am I going way over everyone's head? Apparently I'm doing okay. That's good. Marvellous. I completely understand this. That's good. That means I'm doing something right.
I have a question.
Sure,
so,
go ahead.
as for just like an abstract view on APIs. I think you're doing a great job of explaining it. But as for the actual project, the code you provided, I'm a bit confused as to what the structure is and all the libraries being used and kind of just what's going on. Are you able to do like an overview of the project as a whole?
Yeah, of course I could do that. Is there anywhere in particular you'd want me to start?
Maybe just at the index. Maybe just going into just how you kind of started everything.
Sure, no problem. Just close these other ones. So this is just.
And make sure to switch back to the window.
Oh yeah, thank you. I'm doing a terrible job of that this stream. This one. There we go. That should be switched now. So this particular file, you can view the whole thing on GitHub if you want. The template repo is there, and that's what this project is based off. As for what's actually contained in this file, this is some really standard Node.js startup kind of logic. So you can see that after we've got some imports in there for .env and express, that sort of thing. First thing we do, we initialize .env, we set up the port, or rather we get the port from the environment config. We start express, we include some middleware, so we've got Morgan for login, we've got body parsers so we can actually read JSON that's coming in. And then we create our database connection and we go from there. You can see there's lots of console logs in here because I was frantically trying to debug this at about 3 AM this morning when it wouldn't start up. But I have since fixed that, and I fixed that on the template repo as well, so you won't need to worry about that. There's the synchronized call that I was talking about earlier. That's where TypeORM checks the state of your database versus your entities and then makes any changes to bring them up both in sync. And then this bit would be where the routers get started. So, like I was talking about with the... When I was talking about with the index file in the routers folder, so we've got everything grouped into one single object, that's so you can do things like this. That's where you can import just this one big object that has all of the classes within that folder inside it, and then you don't need to import every single class individually, because that's a pain. Who wants 40 lines of code that don't actually do anything? So we import these routers, and then we start iterating over all the routers that we've got. We instantiate it, and then we take the path, which is defined on the router, and I think the instance.router there, that's the express router, and that's how it registers the class to the actual route to the path. Once it's done that, we just start listening on a port, and then we start receiving traffic. Like I say, you can read through this whole thing if you want on GitHub. Sorry, I cut you off there.
No, awesome. Thank you very much for explaining it.
No problem. Is there anything else you want me to have a look at for you?
No, that was pretty good. Thank you.
Yeah. So we've got controllers. What else was there? Services. Services are another big part of how I like to do things. This isn't necessarily the only way to build, say, an API, but this is the way I like to do it. I like to have things broken out into lots of little pieces, and then that way you only have to fix one little piece rather than figuring out what big chunk of this massive chunk is broken. So I like to put a lot of heavy lifting into services. In a nutshell, these are just standard TypeScript classes. This is where I tend to put all of my logic that uses the database, because a lot of the time your logic, which is pulling things from the database, doesn't actually change. So you can just put it into one file and then expand upon that file as you need to. When a service is instantiated, we make a call to TypeORM to get the entity manager from it. And TypeORM's entity manager is all kind of weirdo, wonderful bizarreness. Hundreds of thousands of lines of mind-bending code, which works with your database, but it's absolutely beautiful. So we get the entity manager, and then we tell the entity manager to get the repository for a particular entity. So this is following what's called the repository pattern. I'm sure there's people that are watching the stream that would like to argue with me night and day about repository pattern versus active record. But in a nutshell, these are just styles of working with a database. Active record it tends to be you pull a record out, you make changes, and you insert those changes immediately. The repository pattern is more about pulling out something which represents that whole table from the database, making lots of changes and submitting lots of changes back at the same time. They each have the merits. I like repository pattern, so that's what this is using. But it can be a little bit confusing to get your head around when you first get started with it.
Why did you choose the repository pattern exactly?
Again, I think it's force of habit, really. I got started with the repository pattern a few years ago, and it's just kind of stuck with me.
I mean, is it better than the other alternative?
I think it largely comes down to what you're doing with it. The repository pattern it's usually a nightmare to get started with in the beginning, but then when your application reaches what I like to call the magical 1,000 commit mark, you're so glad you've done it, because it keeps things structured and sensible, whereas active record, in my experience anyway, has a habit of getting very messy. Lots of if statements and weird edge cases that have been caught, but you don't really seem to have that with the repository pattern.
So like it scales better.
I think it does, but again, I'm sure there's people that would argue that active record scales just as well. It's kind of a personal choice thing. I just like the repository pattern.
All right. Thanks.
So it's definitely worth trying them both out. If you use Laravel, the Eloquent ORM that's in there, that's all active record. If you use Doctrine, which tends to be a popular choice with, say, Zen Framework in PHP, that's a repository pattern. It's definitely try them both out, see what you think. This is just what I like.
Because right now I'm using like TypeScript and just Express, like Bareback Express.
Yeah.
But I'm trying to move my design to more domain-driven development.
Yeah.
Domain-driven design, and I've read that the repository pattern is one of the main basics of DDD. Anyway.
I think it can be. Again, it all depends on what you're doing with it. It's worth trying both out and seeing how they work.
All right, thanks.
So another big one, another important thing that services do is they create data. They also update and delete it. I've just not implemented it here. When you create data, something that you must do at all times when you are building an API, you must sanitize input and you must validate input to within an inch of its life. Because with an API, you can't give visual feedback as to what's going wrong. The only way that you can communicate something's wrong is through JSON. So you need to have very, very robust validation validation of any data that comes in. Check everything. Absolutely nothing should be taken for granted when you're working with an API. If you need a field to be there in an entity and it's not there, it is perfectly okay, in my opinion, to completely throw the towel in and immediately return a 400 response and say, nope, not acceptable, do it again. When you're working with an API, it's the structure of the data that's coming in is all determined by you. So you get to determine what shape the data takes when it comes to you, and you get to determine what the rules are, which is one of my favourite things, especially if you like changing the validation rules to mess with the front end. So validate data, validate it all over the place. There's no such thing as too much validation on an API. Error handling goes hand in hand with validation. You need to be able to do that gracefully. So you need to be able to catch errors whenever they come up, and you need to be able to return a response back. Because if your API stops running, if something's completely blown up, you can't return a JSON response. So you'll find a lot of try-catch in APIs, a lot of it. Use a lot of try-catch, handle errors gracefully, validate everything to within an inch of its life. There was another point I had there, but I've already forgotten it. I'm doing a great job at this, really, aren't I? You get the idea, though. It's all about making sure that everything is handled, because you're going to receive all manner of unexpected weirdness in an API. One thing which has tripped me up in the past, which would be a pro tip that I'd recommend that you implement, is checking the content type of data that's coming in. So if you have a look at Postman, which I will change the window, I've remembered this time. That should have changed. If not, it will do soon. So in Postman, you can change the content type of data that you're sending to an API. And the way that you do that is by checking one of these radio boxes under the tabs here. So you can see that we've got form data, form URL encoded data, and then we've got raw. The majority of the time working with an API, you'll be accepting and sending JSON output and accepting JSON input. But something which can trip you up if you're not checking the content type is that somebody can send you form URL encoded data instead of JSON, and then all of a sudden everything goes completely to pot. So it's worth checking somewhere, usually early on, whether you're actually receiving the right type of data. And if not, return a response and tell them, no, not accepting this, I want this. That's perfectly okay. Your domain, your rules. I've lost track of how long I've been live, actually. Is everyone getting a bit fed up, or would you like to carry on?
You're good to continue.
Cool. I think I'll go for... How long we got? I'll go for another 10 minutes, and then I'll call it there, because it's going to be approaching information overload for everyone. What was the next thing? We might as well have a look, actually, at a database while we're here. So I'm just going to fire up DataGrip, my tool of choice. I'll change the window when that's open. And I'll give you a quick demo of TypeORM doing its thing with a database. It's marvellous. If I can find it, that is. There we go. Try change windows. There we go. That should have got it. So I believe the database that we're using is to do API test. That's for this one. So what I'm going to do, I'm just going to completely purge the contents of this table, and then I'm going to show you TypeORM working its magic once it's done querying the entire contents of this Postgres instance. When you're ready, DataGrip, when you're ready. No other questions? Hopefully I'm still making sense. I feel like I'm getting off track. This is taking absolutely forever.
I didn't follow from the start, so what did you start exactly?
Started with, well, from the very start, as in the start of the stream.
Yeah.
Oh, we started with a couple of slides explaining what's going to be going on and what we're building. And then we jumped into walking through the structure of the project and explaining a couple of things, how they work.
Right.
Apologies for light theme, but it appears everything's broken. So if you have a look, this is the user table of this particular application. It's got all the data in it, it's all populated. And one of my very favourite things about using TypeORM especially is you can just completely purge the entire schema. And let's just recreate that. So you can completely purge it, that's totally gone, there's nothing in there now. And just by restarting the application, I'll just restart this, I won't change the window for it. So the application's been started back up again. If we refresh this, see we've got tables, we have the same tables back again. Of course they're empty, but TypeORM has automatically seen that our database does not match up with our entities and it's done the necessary changes to make that line up. So we have a user table, it's blank, but it's there. And we've got the other two tables as well, which are refresh tokens and to-dos. So you have the confidence when you're using something like an ORM to just completely purge your database at any time. And the ORM will just recreate it for you, minus the data. That's why I like tools like this so much, because it just makes the whole set up and tear down process so much faster. I'd recommend in your own projects trying to find similar alternatives. So just find tools that make projects a one-click start up and tear down, because it just makes the whole process go so much faster.
What would be a good alternative for type ORM?
Type ORM Sequelize is one that I've used. I've had a few issues with it on TypeScript, but it is a very good ORM, is Sequelize. Bookshelf is another good one, although I've not used that, so I couldn't really help you there. If you're using...
Is Mongoose considered an ORM?
I'm not actually sure. I've not really done much with Mongoose. I don't really work with NoSQL, so I've not really used Mongoose. I'm still very old school there.
You're not working with MongoDB?
No, this is Postgres
yeah,
for this
yeah,
project.
It's both screen. Yeah. Sorry, I didn't see that.
If you're using PHP, a fantastic type ORM alternative for PHP would be Doctrine ORM. That is... Oh, it's magical, is Doctrine. I absolutely love it. It's fantastic. It's one of the only reasons why PHP is actually good for building APIs, because Doctrine. Sorry, I think I cut you off there. Were you going to say something?
No, I just told you to. Thank you. And
No problem.
Isn't PHP too slow for building like APIs and microservices?
I've never really had an issue with it. If you've got it on a server which has the horsepower and you write efficient code, PHP is just as good as like JavaScript or TypeScript. Because it's not going to be as good as something which is compiled, like C# or maybe Java, but it is still a very good alternative.
Right.
In the beginning, though, when your project's still getting off the ground, functionality is more important than speed and scale. You can worry about speed and scale when you've suddenly got an influx of tens of thousands of users that you weren't expecting, like everybody does. Nobody scales until they realise they have to.
Yeah, but it's better to just start using Node.js from the start and think of the future.
I mean, make a choice and stick with it. Sure, there's no point really optimizing for scale that you might not need. If you pour lots of money into building like infrastructure and using languages that are slower to work with, slower to iterate over, like Java, C#, then it's going to hurt you in the long term, because if you end up with 3 users and that's it, you never get any more, you've just poured loads of money and loads of time into something that didn't work. That's where the appeal of things like Node and JavaScript come from, because you can just endlessly iterate at maximum speed. And then if you do need to actually scale and switch to something which is faster, then that's when it's time to start looking into doing that. But up until that point, there's no point really. At least that's how I think of it, and I don't know if anybody else thinks the same way. But I just think premature scaling I just think it's misguided. I think we're approaching... Yeah, it's 58 now. So I've got 2 minutes left. Anybody got any more questions? Otherwise, I think I'm going to call it there. In that case, I think we're all good. The next stream will be next Sunday, do 9 PM, and then we're actually going to get started writing some code. It was my intention to start writing some code this stream, but got a little bit lost in explaining things in possibly too much detail. So thank you very much for joining us, and we'll see you again next Sunday at 9 PM. Bye-bye.